Welcome, dear students. In today's lecture, we are going to learn coordinate geometry. Well, coordinate geometry is a chapter in which we will be learning about the graph portion. Right? Now, first of all, let's give a brief introduction what a graph looks like. So, graph is kind of a thing which is divided by a horizontal line and a vertical line. The horizontal line that you can see over here is known as x-axis, and the vertical line over here is y-axis. Right? Now, x-axis represents this point where the horizontal and vertical, or I would say x-axis and y-axis meets. This particular point is known as origin and has the coordinate as 0, 0. X-axis and y-axis divides the plane into 4 equal parts. These 4 equal parts are known as quadrants. These are quadrants. So, since the central angle is 360 degree, right? So, each quadrant measures 90 degree. So, every quadrant is of 90 degree. So, from here we will see that any coordinate can be written as x, y. So, this is how you represent a coordinate, where the first one is abscissa and second one is ordinate, right? Where x is the perpendicular distance from y-axis and y is the perpendicular distance from x-axis. So let's see that if this is a coordinate, this is written as 5, 4. It means the abscissa is 5 and the ordinate is 4. Now what is 5? 5 is the perpendicular distance from y-axis, hence it is known as abscissa, and y, that is the ordinate, that is the 4, is the perpendicular distance from the x-axis. So here we have listed it. X-axis is a horizontal line. Abscissa, what is abscissa? Abscissa is the distance from the y-axis. So what kind of a distance it is? It is a perpendicular distance. So over here the abscissa is 5. Abscissa is 5. So I will say 5 is the perpendicular distance from the y-axis. Right? Similarly, y-axis is denoted by a vertical line which is ordinate. So here the ordinate is 4. Now what is 4? 4 is the perpendicular distance from the x-axis. So it is the perpendicular distance from the x-axis. Again, if a point will lie on x-axis, so its ordinate will be 0, just like this. This is 7, 0. So this will make you understand much clearly that x, that is the abscissa, is the perpendicular distance from y. Since it does not have any perpendicular distance from x, so therefore y or ordinate in this case is 0. So if there is a point that lies on x-axis, a point lying on x-axis will have ordinate as 0, right? Similarly, if I plot 0, 6, this is 0, 6. Again, this is the perpendicular distance from the x-axis. Since perpendicular distance from y-axis is 0, so I will say ordinate is 6 and abscissa is 0. So a point lying on y-axis, in this case abscissa will be 0. So by this you can plot such numbers. So the x-axis and y-axis divides the plane into 4 quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant. So x and y both are positive in first quadrant, like this 5, 4. In second quadrant you will see that x is negative but y is positive. So it is abscissa is negative and ordinate is positive. For example, minus 3, 2. In this one, third quadrant, both x and y will be negative. This is an example for that. This is minus 4, minus 3. In this case, you will see that this is the fourth quadrant. X will be positive and y will be negative. abscissa will be positive and ordinate will be negative. So this is an example 3 comma minus 5 where abscissa is positive and ordinate is negative, right? So the distance between point A, that is 3 comma 5, and B 7 comma 8 can be found out by a formula that is known as distance formula. So AB is given as x2 minus x1 whole square plus y2 minus y1 whole square. Now how did we get this formula? Let's come on to that. Again, this is a coordinate system in which we have plotted point A, that is 3 comma 5, and we have plotted point B, that is 7 comma 8. Now we know that this is abscissa, this is ordinate, this is abscissa, this is ordinate. This is the perpendicular distance from x-axis, this is the perpendicular distance from y-axis. Similarly, perpendicular distance from x-axis and perpendicular distance from the y-axis. Now, we have to find out the distance between this, which I have denoted with the positive line, and that is slant, just like in hypotenuse. So, if I look at very closely that this thing, how are you supposed to find this thing? This is final minus initial, right? So, the final is x2, that is 7, and the initial is 3, so you will have 4 units traveled over here. And in this case, the final unit is 8 and the initial unit is 5, so 8 minus 5, this will become 3 units. Now, I can write that since this line is parallel to this line and the distance between two parallel lines is same, so I would say if this is 3 units or 4 units, so then this shall also be 4 units, right? Similarly, again these two are parallel lines, the distance between these will also remain same. So if this is 3 unit, so then I'll say that this one is also 3 units. Now, since this forms a right angled triangle with one side being 3 and the other side being 4, so isn't it the hypotenuse that I am supposed to find? And to find out the hypotenuse, we know that as per Pythagoras theorem, the formula goes p square plus b square. This will be h square. And if I put the under root over here, I will be able to find out the h. So, if p square plus b square was h square, so h can be written as p square plus b square over under the root. So, we are doing the same thing over here. But instead of p, we have this x2 minus x1. And y2 minus y1 instead of b. So I can write that b square can alternatively written as x2 minus x1 whole square, and b square can also be written as y2 minus y1 whole square. So ideally you are just finding the hypotenuse whenever you are finding the distance. So in this case we will say that x2 minus x1 will give you one length, that is the side on the x-axis, and y2 minus y1 will give you the length that is on the y-axis. So similarly, we'll put it in the formula that x from here will be the final minus initial, 7 minus 3 whole square, and the y over here will be again final minus initial, that is 8 minus 5 whole square. So now this will be 4 square plus 3 square. Now this shall be 16 plus 9, which becomes 25, and the distance between these 2 points will be 5. Right. So whenever you have to find the distance between two coordinates, you can use this formula. This is known as distance formula, and we have just showed you that how it was proved. So this is x2 minus x1 whole square plus y2 minus y1 whole square. Right. Now there are two more type of questions based on distance formula. The first one is find the x, or if you have to find any unknown value, if the distance between the points A and B is given. So as per the distance formula, x2 minus x1 square plus y2 minus y1 square is the distance, right? So x1, y1, x2, y2. Since it is minus 1 over there, this minus into minus will be converted to plus. Now what I'll do is, I'll do squaring both sides. Squaring both sides. Now this will give me an idea that this is 3 minus x whole square plus 3 whole square. This is 5 whole square. Now the root will go away because I have squared it. Now again it will be 9 plus x square minus 6x. This is a square plus b square minus 2ab plus 9 is equal to 25. So now this is a quadratic equation. Now we'll solve it by middle term splitting. So I need the product to be 7 and the sum to be 6. So this shall be minus 7x plus x minus 7 is equal to 0. So x minus 7 plus 1, x minus 7 is equal to 0. So x plus 1 or x minus 7 is equal to 0. So either the value of x is minus 1 or x is 7. Right? So the coordinate of this A will be either minus 1 comma minus 1 or it can be 7 comma minus 1. Okay? Now type 2. Now in this case they will be using the term equidistant, that a point which is equidistant. Now what does this mean? That if P and R are 2 points and Q is over there, the distance between PQ is same as that of a QR. Right? So Q is said to be equidistant from P and R, means PQ should be equal to QR. So I relate it like this, that PQ should be equal to QR. Now I'll put the distance formula. First of all, in PQ, this will be 5 minus 0 whole square plus minus 3 minus 1 whole square, which is equal to x minus 0 whole square plus 6 minus 1 whole square. Now root and root get cancelled out because they are on the term of the equal sides. Okay, now this will be 25 minus 4 plus 16, which is equal to x square plus 5. So 5 square, that is 25. Now this 25 and this 25 get cancelled out. X square is equal to 16, x comes out to be plus minus 4. Now why plus minus is being generated? Because plus 4 square will also be 16 and minus 4 square is also 16. Then after this we will be discussing questions about collinear, because in this case even you need distance formula. But since collinear can be solved by 2 formulas, so either you can put it in the area of the triangle or you can also use it by the distance formula. So collinear are the points which lie on the straight line, right, on the same straight line. So if let's say A and B is a straight line, then point C, so A, B, C will be collinear if AC plus BC becomes equal to AB. So you can get it from the distance formula that if sum of the distance between these 2 points is equal to the final distance, then we'll say the points are collinear, right? Now the fourth category in distance formula is collinearity, which we have just discussed, that the points will be collinear if the point lying in between them, the AC or BC, is equals to AB. So the question comes like this: check whether A, B, C are collinear or not. We'll first apply it on AB, then we'll do it for BC, and then we'll do it for AC. Now for AB, it will be minus 2 minus 1 square plus 7 minus 1 square. This becomes minus 3 square, that is 9. This becomes 6 square, that is 36. This becomes root 45. Now BC, this will be 3 plus 2 whole square plus minus 3 minus 7 whole square. Now this will be 5, that is 25. This will be 10, that is 100. So this comes out to be 125. Now for AC, this will be 3 minus 1 whole square plus minus 3 minus 1 whole square. So now this will be 2 square, that is 4. This is 4 square, that is 16. This is root 20. Right. Now we can further solve them out. Yes, I can say that AB plus AC is equal to BC, because 3 root 5 plus 2 root 5 is equal to 5 root 5. This is 5 root 5, which is equal to 5 root 5. Now since we didn't know that which of the following point is in between the given 2 points, so in this case you have to find all the 3 distances AB, BC and AC. So this is how we got it. So after we are done with the distance formula and we have discussed the 4 types of the distance formula, the next formula in coordinate geometry is section formula. So whenever a line is divided or intersected or a point coincides them, it does in a particular ratio. So let's say if the ratio is m ratio n. So now it can be the point P intersects AB in m ratio n, or it can be a line CD intersects the line joining AB at point P in m ratio n. So the section formula for the abscissa of this point capital X will be mx2 plus nx1 over m plus n, and for ordinate it will be my2 plus ny1 over m plus n. Right? So now let's take an example. The question can be in this form: point P intersects line joining A minus 1 comma 7 and B 4 comma minus 3 in ratio 2:3. Find the coordinates of point P. So we'll take this as minus 1 comma 7 and this as 4 comma minus 3, and the ratio is 2:3. Now we'll apply the same formula over here. X is, now m is 3, 2 and 3, so then this will be 2 into m into x2 plus n into x1 over m plus n, right? And for y it will be m into y2 plus n into y1 over m plus n. So now this will be x is equal to 8 minus 3 by 5 and y will be minus 6 plus 21 by 5. So this comes out to be 5 divided by 5, that is 1, and this comes out to be 15 divided by 5, that is 3. So the coordinate of the given point will be 1 comma 3. So you can find it out like this. Type 2 for section formula will be find the ratio in which point P minus 1 comma minus 2 minus 1 comma 2 divides the line segment joining A 2 comma 5 and B minus 5 comma minus 2. So in the previous question the ratio was given to me, coordinates were given to me, I have to find this coordinate. In this question these 3 coordinates are provided to me, I have to find out the ratio. So whenever you are supposed to find out the ratio, you will take the ratio in any of the variable form. So we'll assume let the ratio be k ratio 1, right? You can take it as p ratio 1, you can take it as lambda ratio 1, you can take it as any value that is d ratio 1. Let's proceed with the question. Now a is 2 comma 5, b is minus 5 comma minus 2. So now we'll see if I have to find out the ratio. X will be k times, because this is k ratio 1 now. So mx2 plus nx1 over m plus n, and y will be my2 plus ny1 over m plus n. Now m is k and n is 1. Now we'll substitute the value of x. X over here is minus 1, which is minus 5k plus 2 over k plus 1, and y over here is 2, so this is 2 is minus 2k plus 5 over k plus 1. So now this becomes minus k minus 1, which is minus 5k plus 2. This is 2k plus 2, which is equal to minus 2k plus 5. Now this becomes 4k, which is equal to 3, and this becomes 4k, which is again equal to 3. Now k comes out to be 3 by 4. K comes out to be 3 by 4. Now since the ratio was k ratio 1, so we'll take it as 3 by 4 ratio 1. This becomes 3 ratio 4. So I can write that the ratio in which the point P minus 1, 2 divides the line segment joining point A 2 comma 5 and B minus 5 comma minus 2 is 3:4. Right. So this is how you will proceed with the section formula when in first case a ratio is given, you have to find out the coordinate of this. Second case, the coordinate of this point is given, you have to find out the ratio. And whenever you have to find out the ratio, you will take it as some variable with respect to 1. So that even if it comes in fraction, the original ratio is in the whole numbers. Right. Then we have one more thing over here, that midpoint formula is a special case of section formula where x or m is equal to n, which becomes 1. So instead of m ratio n, it is 1:1. Only then it will be a midpoint. So this will be -3/2 and this will be 7/2. So the coordinates of C will be -3/2, 7/2. So midpoint of these 2 points will be -3/2 and 7/2. One more application for this section formula is centroid. Now what is centroid? First of all, now if ABC is a given triangle, so then AD is a median on BC which bisects BC, and CF is a median on AB which bisects AB, and BE is a median on AC which bisects AC. So the point of intersection where these three medians will meet, that is known as centroid. So centroid is denoted by G. Now the main thing about centroid is that it divides the median in 2:1. So 2:1. So I'll say AG ratio GD is 2:1. BG ratio GE is again 2:1, and CG ratio GF is also 2:1. So whatever the median it is, the point centroid divides the median in 2:1. So the formula becomes, if I have to find out the abscissa, that is x of centroid, so this will be x1 plus x2 plus x3/3, and for y it is y1 plus y2 plus y3/3. So let's see, for an example, if A, B, C are the coordinates of a triangle, that is 2, 3, 4, 7 and 3, 5. So the coordinates of centroid G will be 3, 5. After we have discussed the distance formula, section formulas type and centroid, now comes that is area of triangle. So whenever a triangle with its vertices are given to us, if they have asked us to find out the area of the triangle, so we will not be using half into base into height, we will be doing half into x1, that is y2 minus y3, plus x2 into y3 minus y1, and x3 y1 minus y2. So now let's find out the area of the given triangle if the coordinates are -5, -1, 3, -5 and 5, 2. This becomes 32 square units. Right, this is 32 square units. Now you can also use the same formula for proving the collinearity. Points A, B and C will be collinear if area of triangle is 0. If area of triangle comes out to be 0, the points are collinear, and they will be non-collinear if area of triangle is not 0, and non-collinear if area of triangle is not 0. So I can say that -5, -1, 3, -5 and 5, 2 are not collinear because I have a value over there, that is 32 square unit. It is not 0, hence the points are non-collinear. Right. After the area of triangle, we have just discussed that the points will be collinear if the area of triangle becomes 0. So let's take an example to check area of triangle for collinearity. So now check if A, B and C are collinear. So now I'll put the formula in the area of triangle. So this is half by 2 into 0, the result is 0. Now since area of triangle became 0, so I can say that the points are collinear. Hence A, B and C are collinear, right? So in today's lecture we have studied about distance formula, section formula, midpoint formula, formula for finding out the centroid, to how to check the collinearity by the distance formula and by the area of triangle formula. With this we conclude this video, and we'll be posting out some more videos on the other topics as well. Thank you.